want to show you this problem right now. And since it's very similar to the one we just did before, I would say let's try to do it in MATLAB so that we learn something new. So the problem is asking us to find all critical points of the given plane autonomous system. Now, before we jump into MATLAB, let's look over here for a second and let's try to understand what plane means. Plane means that there's two variables only. So that means that this can be represented kind of like a vector field or in a 2D graph. And then autonomous means that there is no independent variable shown anywhere. As you see, this is dependent and y is also dependent in the system. So they're both dependent variable. So these equations are both autonomous, and since they're two equations linked to each other, they're a system. So let's go over to MATLAB and let's see how we can solve this quickly in MATLAB. So let me open MATLAB over here. And the first thing I'm going to do is I'm going to clear all old variables. And you do that with the command clear all. Another thing I want to do is I want to define some variables because I know I'm going to have two equations that I'm going to define with variables that I want to solve for. And those variables are going to be x and y, and you define them with the command sims. Now, the next thing that we're going to do is we're going to actually solve. So let's solving the system for its critical points. And we use the solve function for that. And inside we want to put all of the equations that we want to solve. Well, in this case, we have a system of two equations. Remember, we're putting the slope equal to 0 because that's what it means to be a critical point. So instead of x prime, we put 0 is equal to, and equality is given by a double equal sign in MATLAB. It's equal to x plus x times y. Then we put a comma to signal to MATLAB that we're passing to the second equation. And it's also going to be y prime is going to be 0. We're setting the slope to 0. That's what it means to be a critical point. Minus y minus x times y. We put another comma now, and now we want to specify what we want to solve for. We want to solve for x, and we want to solve for y. And this is how you specify. Then we put another comma, and now we want to specify to MATLAB that we only want real answers, and then true. It's something that gets associated with real. I'm not sure why, but I've been told to put it in. And then we know that this is going to output an x and a y, so we want to specify where to output that. And I'm going to give it a different name because for future exercises, it's going to be useful to have a different name. And then hopefully, if we typed in everything correctly, we can press Control Enter. And since we didn't put a semicolon here, we're going to get the answers. And these are going to be pairs. So the first entry here is going to be with the first entry here. And the second entry here is going to be with the second entry here. And if you had any doubts, you could check, let's say this one, or we could check both. Let's say we want to check both. So I'm going to copy them, and I'm going to check my answers. And what I know is that this right-hand side has to be equal to 0, right? So let me just say I want the first entry of my x solved, which is going to be this one. And same for this. And same for this. And same here, and same here. And I want to see if I get 0 with these. Do I get 0? This is the million-dollar question. Now they're saying, hey, indices must be positive integers, so I think they want us to start at 1. And I started with 1, and then I put everything else at 0. So the 1 is the first entry, and we get 0, 0, so we're confident this is a solution. I hope this was useful because we'll build up on this to do other things later in the chapter, and I'll see you there.